So here, as I told you, the pressure difference exists. Pressure here is high, pressure here will low. Once it uncovers, this charge will come here. Okay. Now, what happen is, if I draw the position of piston as like this, let's consider that position of piston is somewhere here, which has uncovered the transfer port. Deflector is this one. So this is top of the piston. When fresh charge is coming like this, it doesn't move horizontal like this. Because of deflector. Because here, as deflector is present, so it will move up. It will move up. And in this zone, there will be exhaust gases. So exhaust gases will get pushed forward. So exhaust gases goes forward, and the fresh charge will occupy into this particular space. Okay. Now piston has reached to BDC. So what has happened when piston is traveling from TDC to BDC? The spark has occurred. Because of occurrence of spark, high pressure is generated. Because of high pressure generation, piston moves on downside direction. As it moving on downside direction up to exhaust port, it is acting as a closed chamber. Once it uncovers exhaust port, all exhaust gases moves out. Once it uncovers transfer port, the charge which is present on a downside direction, air plus fuel, that will come up and it will occupy into the upper space. So the expansion and exhaust both has occurred when piston is moving from TDC to BDC. So for the exhaust also, piston is moving from TDC to BDC. Okay. So these two processes, expansion and exhaust, both processes are taken place when piston is moving from what? TDC to BDC. So for completing these two processes, I required a one stroke, which is from TDC to BDC. Now let's assume that the piston is at BDC, and it starts moving on upward side direction. While moving on upward side direction, what happen is it will cover first the transfer port. It will cover the transfer port, then it will cover the exhaust port. What is above the piston? Above the piston is air plus fuel, which has entered from transfer port. Now above the piston is air plus fuel. First of all, it will cover the transfer port, then it will cover the exhaust port. Once it cover these both, and when piston is somewhere here, and when it is moving on upward side direction, this has formed now closed chamber. And in a closed chamber, if piston moves on upward side direction, the process takes place is the compression process, because we are reducing a volume, and because of that pressure will go on increases. So that's why as piston moves on upward side direction, the compression process occurs above the piston. What happens below the piston? On the downside of the piston, when piston moving on upward side direction, space below the piston increased, and as space below the piston goes and increases, what is generated is the vacuum. So in the crankcase, vacuum is there, and outside is the P atmospheric. Now what happen is, because of this pressure difference, here is vacuum, here is P atmospheric. P atmospheric is more than vacuum, that we are knowing it. Because of this pressure difference, the valve which is present here, that will get open, which is pressure operated valve, which works on the pressure difference. So if pressure on this side is more, then what will happen? It will open on inner side. So once it opens on inner side, the fresh charge will come inside. Remember, what is happening above the piston is compression. What is happening below the piston is suction process. How suction process? Because outside charge is entering into the system because of vacuum generated. Right? So the charge has came inside below the piston. Above the piston, compression has occurred. So two processes completed, compression and suction. So I will see here suction and compression. In these two processes, how piston has moved from BDC to TDC. So piston has moved from BDC to TDC. Once piston reaches to TDC, once again spark will occur. And as spark will occur, the pressure will be generated. As pressure generated, piston starts moving on downside direction. As piston moves on downside direction, first it will uncover the exhaust port, and that's why all exhaust gas goes outside. Then it will uncover the transfer port, and that's why fresh charge, that is air plus fuel, will enter above the piston. enter above the piston. Okay, that is what the case. So for completing suction and compression, we required one stroke. For completing expansion and exhaust, we required another stroke. So how many strokes we required? We required 2 strokes. So this is one stroke and this is another stroke, 2 stroke. For completing what? For completing 4 processes. So 4 processes, nothing but what? 1 cycle. So for 1 cycle, we required 2 strokes of the piston. We required 2 strokes of the piston, and that's why it is called as 2-stroke engine. This particular engine is called as 2-stroke engine. Now, as I told you that there is a deflector provided over the piston. Now, what is function of deflector? That you must know. Now, let's consider piston is present here and the deflector is on this side. Now, if deflector is not provided, the fresh charge may come like this and it may enter like this and it will go out from the exhaust port. So, we may get wastage of the fuel because if deflector is not present. If deflector is present, then the charge will move upward side direction and pushing the exhaust gases forward side direction. So what will happen? Wastage of fuel will get reduced, and that's why we are getting what? We are having a deflector on the piston for the 2-stroke engine. For the 4-stroke, we are having separate stroke for the exhaust process, and that's why the deflector is not required. That is what the specialty in this case. Now in this case, advantage of 2-stroke engine, if you observe carefully, in 2-stroke engine power output we get with the same size of engine is more. At the same time, bulk of the engine is less. So weight of the 2-stroke engine will be less for same power output. These are 2 major advantages. Whereas disadvantage, if you consider, the thermal efficiency is less because there is a wastage of fuel, as we have seen. Next disadvantage, there is a scavenging problem. Now what is scavenging? Removing exhaust gases from the engine. That particular process is called as scavenging. So removing the exhaust gases from the engine is quite difficult here. Why difficult? Because we are not providing separate stroke here. In a 4-stroke, we had provided separate stroke, and that's why that was easy there. Here we are not providing separate stroke, it's combined process. In the combined process, removing all the exhaust gases becomes quite difficult. So these are some advantages and disadvantages of the 2-stroke engine. Now suppose till now we have discussed a 2-stroke engine, and that is petrol engine. If I make it diesel engine, 2-stroke diesel engine, what will happen? 2-stroke diesel engine, this spark plug, as you know, this spark plug will be replaced by a fuel injector. This spark plug will be replaced by fuel injector, whereas at the inlet only air will come. There will not be a fuel. Now where fuel will be added into the air? Fuel will be added into the air after compression. That's what the difference. 2 differences. One is we will use fuel injector. Another difference is what? Rather than coming air and fuel, only air will be entering into the system. Okay, that is what the case. So that is what only differences. There are some advantages, disadvantages. We will find application of 2-stroke engine where power to weight ratio required is more. Power to weight ratio required is more. What is power to weight ratio? Power to weight ratio is nothing but a ratio of power produced by the engine to the weight of engine. That is what the case. If I want power to weight ratio high, then generally we prefer 2-stroke engine. That is what the case.